simplifying radical numbers, which belongs to the irrational number system. Let's just review a little bit. Irrational numbers. The famous one would be pi. So square root of 2, square root of 3, square root of any prime. What we call radical of any prime would be an irrational number. Radical of prime numbers are irrational numbers, or we call square root. Are irrational numbers. So irrational numbers versus rational numbers. So we just, keep them as they are in college level, or even probably not in high school level. We don't need to approximate anymore. If we sometimes we do, solve life applications. Maybe we want to get an exact number, so we can press into a calculator the square root of 2 or square root of 6, and the calculator will give you a rough approximation. So no one really knows its exact value. That's why it's called an irrational. So it doesn't, human brain doesn't totally grasp such a number yet, but we can always approximate. So sometimes we want to add radicals, if possible, if they are like radicals, just like terms. Okay, like terms, but here we call like radicals. Like radicals. So when we perform the operation of plus, minus, combining them, it's the same way as we adding or subtracting like terms. Let's see the first one. We have 3 of radical 6. Then we have minus 4, or we can think as subtract 4 of radical 6. So radical 6 is a common factor, right? So what do? We just do 3 minus 4. Then multiply by square root of 6. Same way as we combining like terms, we're adding to like terms. What do we add? We add the coefficients of the like terms. So 3 minus 4, well, that's -1. When it's 1, remember, if it's 1x, usually we don't bother to write the 1, we just write x. Same idea. We just write a negative radical of 6. Okay, that's it. Just keep like that. Let's see 2. So we have a radical 7, like radicals. Like radicals means the radicands are same. Radicand means the number under the radical sign, called a radicand. And the index are the same. So where's the index? The index is a little number here. But if the number is 2, we just don't write it. So by default, if no index, the index is 2. And we call this number index. So when the index of 2 radicals are the same, and the radicands are the same, and they are like radicals. In this case, we do see the first one is square root of 6, the second one is square root of 7. Oftentimes I switch with radical 7, square root of 7, they mean the same thing. Okay. Sometimes I don't know why I switch back and forth. So here we also have -3 plus 4, right? So 4 minus 3, that's positive 1. Again, we don't bother to write the 1. We just write a square root of 7. So those two, adding those two, get a square root of 7. Similarly, we identify, okay, square root 21, square root 21, they are like radicals. We just combine the numbers before them. So negative 11 minus negative 11, that's negative 22 of square root of 21. Just like combining like terms. Square root of 15 are like radicals, just combining negative 9 and 10. Again, we get a 1. We don't bother, we don't need to write a 1 in front of anything. So we just write as the square root of 15. Let's see this 4. Maybe now you can do faster than me. Same like radicals. If they are not like radicals, we cannot do anything. We cannot combine them. They are like radicals. So negative 10 plus 12, this is 2, radical 7. Okay, if you can do faster than me, go ahead. So 6, negative 3, negative 4, negative 7. And the like radicals is the square root of 17. So we have to get used to this family of numbers. Okay, they are just radicals. They look a little bit strange, but they are irrational numbers. So this will get a negative 22. We just have to, just make them our friends, not strangers anymore. So negative 22 is square root of 11. And here, okay, number 8 is different from the previous ones. Do we have like radicals? Not yet, right? The radicand here, the first one is 3. The second radicand is 27. But 27 can be simplified. It's 9 times 3. When we square root of 9 is 3. So we get a 3 radical 3 for square root of 27. So 3 radical 3 is a simplified version of square root of 27. So in this case, we see square root of 27 is related with square root of 3. So square root of 27 is in the family of square root of 3 and is 3 times bigger than square root of 3. But this has 3 already in front. We just multiply those two 3's. So we get 9 radical 3. So 3 radical 27 becomes 9 radical 3. Now we have like a radical. So negative 2 plus 9 is 7. So the answer for 8 is a 7 radical 3. So this is saying if sometimes they're not like radicals, we may try to make them like radicals, right? By simplifying one of it. Or maybe sometimes we have to simplify both. Let's see this one. Square root of 6 is the simplest form. But 24 is not. 24 can be split as 4 times 6. Then square root of 4 is 2. 2 times 2, that's 4. So the second one becomes 4 times square root or radical 6. Right? Because square root of 24 is 2 radical 6, because square root of 4 is 2. 2 times this 2, that becomes 4. But we have negative sign, so negative. 2, now we have like radicals of square root of 6. 2 minus 4 is negative 2. So our answer for 9 is negative 2 radical 6. Let's see 10. 54, 9 times 6, right? When we square root of 9 becomes 3. 3 times this 3 becomes 9. So let me write it one more time. So square root of 54 can be simplified as 3 radical 6. But then multiply by the 3 before it already. 3 times 3, that's 9. So we have 9 radical 6 for the second term. Now the second term, 3 radical 54 becomes 9 radical 6. Okay, it's like a radical with 2 radical 6. So 2 plus 9, 11. So the solution for number 10 is 11 radical 6. Let's see 11. Radical 3 is the simplest form. 12 is not. 12 can be split into 4 times 3. So when we square root, we get a 2 radical 3. So square root of 12 is in the family of square root of 3. And it's twice, it's 2 of radical 3. But we have negative sign up front, so we put a negative sign here. Then we add a negative 2 with 3, so we get a 1 radical 3, which is just radical 3. So number 11, just radical 3. Number 12, similarly, 27 again is 9 times 3. Right? When we square root, we get a 3 radical 3 for radical 27. But we have a negative sign up front. This negative sign, so we have second term is a negative 3 radical 3. We have 3 radical 3 minus 3 radical 3. Guess what? 12 is 0. Okay, now let's see this. Last two. Now I have sometimes you have to bear with me because I'm looking for my pencil. I'm switching between pen and going through the next page. I'm using rule, by the way. So number 8 is 4 times 2, right? Square root 2 is 2. So square root of 8 is 2 radical 2. See, when we simplify some certain radicands, right, we see the beauty of it is related with some others. So now we see square root A is 2 of radical 2. But we have 3 here up front. So we multiply by 3. 3 times 2, 6. So the first term becomes 6 radical 2. 6 radical 2 plus 3 radical 2, the second term. So the answer for this, did you get a 9 radical 2? I hope you do. I hope you get a 9 radical 2. That's the answer for 13. Let's see for 14. On 14, we don't have to do anything, right? We have radical 6, we have radical 6, we have like radicals. But one is negative 3, one is positive 3, so they cancel 0. And we call this kind of numbers additive inverse. What does it mean? It means A plus negative A equals to 0. So we call 0 additive identity. And A and negative A, they are additive inverse with each other. Okay, that's addition. That's addition. That's combining, means add or subtract two like radicals, right?